Okay, you are welcome. We'll be looking at solution to some of the Olympiad questions. I mean senior category of the National Mathematics Olympiad competition. So this is first round questions, and in preparation for the next Olympiad exam, we want to look at solution to some of these questions. For question number 1, we have find the area of a circle inscribed in a 5, 12, 13 triangle. 5, 12, 13 triangle, from here you can see that this is a Pythagorean triplet. So it means it's a right angle triangle. From there, let's draw a right angle triangle and inscribe a circle inside it. You can make the triangle to be a little bit bigger. Okay, so inscribe circle inside it. So to inscribe a circle inside it, it means we have something of this nature. We have a circle. This is a circle. We have it inside it. Yeah, don't mind the circle if it is not all that straight. Okay, so from here, from what we can see now, we can see that the size of the triangle acts like tangent to the circle. And don't forget, there's a theorem in circle geometry. The theorem says tangents from an external point are equal. So tangents from an external point are equal. But before we go there, let's label this triangle. We have 5, 12. Let this place be 5. That's the smallest there. Let this be 12, and let this be 13. All right, so from here we can okay, so the tangents are equal. Let the tangent here be x. Let this be x. So if this is x, based on the fact that tangents from an external point are equal, so this is an external point here, so it means tangents from these points are equal. This is x, this is the second tangent. So they are equal, x and x. If you come here too, this is also a tangent from here to here, tangent from an external point. They are equal. So since this is x and the whole of the side is 12, removing this part as x, it means the remaining part is what? 12 minus x. Alright, so that is 12 minus x. So if that is 12 minus x, then this is also what? 12 minus x. Then coming to this side, this is also a tangent from an external point. This is the external point. They must also be equal. If from here to here is x and the whole of the length is 5, then the remaining part, the remaining side of the length of that side is what? 5 minus x. So if this is 5 minus x, this is also what? 5 minus x. From here, you can see that if you add this tangent here, 12, and the tangent here, 12 minus x, add them together, you realize that your answer will be 12. Add the one here, 2 together, x and 5 minus x. Your answer will be what? 5. So definitely the third one should also give us the same thing. If you add 12 minus x and 5 minus x, we should have 13. So let's do that. 12 minus x. Then plus 5 minus x must give us 13. Alright, so if you add that, we have 17 minus 2x equals to 13. Alright, so it means 2x is equals to 4 and x is equals to 2. Alright, so if x equals 2, from here now we also need the center. The center is somewhere here. If you bring, there's also a theorem that says that what? The radius of a circle at the point where the tangent meets, at the point of contact, radius to a circle at a point of contact is perpendicular to the tangent at the point of contact. So if you have a radius drawn to a tangent at a point of contact, is what? Is perpendicular. So this is perpendicular. So from that, since x, this is 90 degrees, this is also 90 degrees, this is 90, 90. So it means it is either a rectangle or a square. But for the fact that the adjacent sides are equal, this is x, this is also x, they are equal, so it means it's a square. So from there we can imply that the radius is also what? X, which is 2. So that's the radius of the circle. The question says find the area of the circle. If the radius is 2, what's the formula for the area of a circle? That's what? Pi r squared. So our r is 2. 2 squared will give us 4. So it means the area is what? 4 pi. Okay, that's the solution to that particular one. Now let's move to the next questions. Question number 2. The mean, median, and mode of the data values 90, 54, and so on. So let's clean the board for this. Assume you have written the whole. Okay. So, alright, so let's do so now the first thing for this, we can see that the mean, median, and the mode are all equal. So the first thing is that let's arrange the data in ascending or descending order. What is the lowest point there? The lowest mark there is what? 54. If we don't know, let's isolate x for now and arrange what we have there. Okay, so arranging them, we have 54, okay, followed by 58, yes, followed by 62, okay, 62, followed by 78, yes, 78, followed by 81, and followed by 90, and 123. How many numbers do we have? 1, 2, 3, 4, 5, 6, 7, 8. So apart from x, it means we have 7. 1, 2, 3, 4, 5, 6, 7. So, and then x will be anywhere. Now from here, let's see. One of those things that we need to look at is that x can be anywhere here now. Now, how do we get the median? The median is the central number, the one occupying the central position. So from here now, we have 8 numbers, 1, 2, 3, 4, 5, 6, 7 with x. So it means there is no central number. It must be between 2 numbers. It must be between 2 numbers. That's number 1. Now, another thing is the mode. So it means we are going to see our median around this. Okay, another thing is the mode. The mode is what? The number that occurred most. It is glaring now that what? There is no number that occurred most here. All of them are single number. Okay, so they occur just once. So what that suggests is that our x must be a value from this. Yeah, our x will be a value, even one of the values at the middle, so that that value can be can occur 2 times and be the mode. And that same value will also be the what? The median. And that same value will also be the what? The mean. Now let's see, it means it must be the one at the middle. So let's stretch out what are the numbers at the middle now. 1, 2, from here now, 78 is occupying the middle position here because we have 7 numbers. So it means if x is also 78 and is at the middle, it means that our median will be 78 plus 78 over 2, which will still be the same thing as 78. I hope you get that. Yeah, so we have said that definitely, because they said the mode, the median, and the mean are equal. From here now, neglecting x, we can't get our mode. There's no value that occur most. So it means, then another thing is that the median must be at the central, the middle value. So the median is between 78 and maybe 62 and 81. So from here now, if you can place our x to be at the middle beside 78 and at the same time 78, so we realize that we are going to have the same thing as the median and the mode. So we can also try that for the mean. But what this signifies is that what? The answer is 78. The answer is 78. Now the next question, number 3. It says if x is equals to 1 plus square root of 2016 divided by 2, then 4s cubed, that's 4s cubed, minus 2019x minus 2017 equals what? Now let's see how we can do this. Okay, let me clean this. Okay, yeah, so what do we do here? Now one of those things, can we just simplify this? If you simplify that, we have 2x equals 1 plus square root of 2016. All right, so from there what do we do? From here we can take minus 1 to the other side. We have 2x minus 1 equals square root of 2016. If you square both sides, then 2x minus 1 squared will be equals to 2016. All right, we can just expand that. If you expand that, what do we have? We have 4s squared. We have 4s squared minus 4x plus 1 equals 2016. All right, so equals 2016. Okay, so minus 1 can go there, so we can see that 4s squared minus 4x equals 2015. Okay, all right, I think let's just leave that now. So it means we can simplify what the value that has been given as x to be this. Now let's come to the value we are looking for, the expression. So we have the expression 4s cubed minus 2019x minus 2017. Now can you see that x is common here? Bring out the x. So we have x into bracket 4s squared, all right, minus 2019 minus 2019. Okay, 4s squared minus 2019, okay, minus 2017. Okay, so in this case now let's see 4s squared minus 2019. Let's see. Okay, from here let's find the value of 4s squared here. So possibly we can substitute 4s squared from here. We can say that 4s squared is equals to 4x plus 2015. Okay, 4s plus 2015. So let's substitute. So we are going to have x into bracket 4s squared is now what? 4x plus 2015. Okay, so minus 29 like you have here, so put it minus 2019 minus 2017. All right, so from there we have 4x, no, x into bracket 2015 minus 2019 will give us what? Minus 4. Okay, before x minus that's minus what? Minus 4 minus 2017. We are just trying to manipulate those figures. Let's see whether we can get something great out. So from there, if you multiply this, what do we have? We have 4s squared minus 4x. 4s squared minus 4x. 2017 minus 2017. All right, I think we have seen something out now. 4s squared here, it is same thing as 2015. So replace 4s squared minus 4s will now be what? 2015 minus 2017. So 2015 minus 2017 will give us what? Minus 2. Minus 2. So that is the solution to that. So the answer is minus 2. So that figure is minus 2. I want to believe you understand what I've explained now. So let me just recap again. So you just find the value of cross multiply, get 2x minus 1, square it, and you have this. So you can just go through it again. It's recorded, so you can always play back. Alright, so that is solution to that. I will move to question 5 now. I'll move to question 5. Okay, so we may need to omit some questions which I will do later. Okay. So, alright, the next question, number 5. Determine the last 2 digits. Determine the last 2 digits of okay, sorry, let me erase that. Okay, so determine the last 2 digits of 2016 raised power 2017. Now 2016 raised power 2017. When you have some of these questions, 2016 raised power 2017 as 2016 raised power 2017. So we need last 2 digits. So in this case, you should know that the major concern is also the 2 digits here. Is the major concern. Is the one that will determine the last 2 digits in the whole. So one of those things we can look at here is let's see what will happen by the time we multiply numbers 16. So it means we could say that what we need there is the last 2. 16 raised power 2017. Okay, so how do we do that? By the time you try 16 powers of 16, let's see how we can try powers of 16. 16 times 16 is what? 256. So that is 16 times 16. Let's see. 16 is same thing as 2016. If you multiply 2016 by 2016, you realize that the last 2 digits will be what? 56. Power of 1, it will still be, if it is just 2016 raised power 1, the last 2 will be what? 6. Okay, so for the next one, 16 raised power 2 will be the same thing as 2016 raised power 2. So what will you get there? You should get that 16 square is 256. So it means you are getting 56. So you are getting 56. So you can try that. Now when you do the next one, 2016, you can also try 16 raised power 3. Try raised power 3 and see what the last. Now you realize that it's 96. You can try that. So let's continue. 16 raised 4. 16 raised power 4. If you try that, you get what? 36. 36. Okay, so go to the next one. 16 raised power 5. Power 5. You get what? You get 30. Okay, that's 76. 76. You can try to do that. Okay, now
2 digits.
Are circular in nature. Powers are circular in nature. So we realize that it will be going round. We'll be going round. So as we are getting 16 now, the next one, 16 raised power 7, will be what? It means it is 56 that we end it. So it is circular in nature. It's circular. So it means the modulus for this one is just is 6. So when you get to the 6th one, you go back to the first one. So how do we now apply that principle to do for 20 raised power 17? So you can see now that for what you can see here is that if it is multiple of 5, by the time you are doing it, you can see 1 for 5 we are getting 76. So it means 16 raised power 10, it will also end with 76. 16 raised power 15 will end with 76. 16 raised power 20 will end with 76. So all those factors of 5 like that, they will continue to end with what? 76, 76, 76. And the next one to the factors of 5 will end with what? 16. So now, look at this. From here, we can see that 2016 raised power 17. Let's use factors. So it means 15. 2015 will be a factor of 5.
Ten, 11, and so on be the increasing sequence of positive integers that are neither square nor cube of integers. Find the 2016th term of this sequence. Now, how do we get this? We want to find the 2016th term. So what are some of the things that you need to look out for here to be able to find that? Now, they have told us, you can see there are some numbers that are not there. The numbers that are not there, they are not there for the fact that they are square or cube. So any number that is a square or cube will be eliminated. So let's see those numbers that are not there. You can see that 1 is not there. Why? Because 1 square is 1. So 1 does not belong to that category. Okay, so that is why 1 is not there. Okay, so you can see that 4 is not there because 4 is same thing as 2 squared. So all those numbers that are not there, they are not there for the fact that they belong to square or cube. Okay, so let's write out. So 1 is not there. We have 2. We have 3. 4 is not there. 5, 6, 7, 8 is not there because 2 cube. So 9 is not there because of 3 squared. Okay. Of that sequence. Now, what we just need to do is that from here now, we can see that we can fashion out our Tn. Let's fashion out our Tn. So it means our Tn is like to be n. Our Tn should be n. The first number should be 1. But for the fact that 1 is not included, it is part of those numbers that are not there. So that is why we are not putting it there. So it means Tn will be equal to what? N plus number of exceptions will be equal to n. So because we have exempted some number, exactly, let me explain. Number of exemptions where n is not equal to 1. Yeah, okay, no, it's correct. N is for all. Look at 2 for example. 2 is T1, so the same thing as T1